Hello everyone, welcome back to my channel. So in this video we are going to learn about plane wave characteristics. Okay, plane wave characteristics in good conductors. Okay, plane wave characteristics in good conductor, that is when wave is traveling in good conductor medium, then what will be the characteristics of that wave. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, so what is the condition? Directly we can enter into the condition. So condition here is, I have already explained you the conditions for different medium when I am discussing the concept of loss tangent. Okay, sigma by omega epsilon is very much greater than 1. So when this value is very much greater than 1, so omega epsilon by sigma will be very much less when compared to 1. Okay, so in this case what will be the propagation constant? So actual formula is j omega mu into sigma plus j omega epsilon. Sigma mu, okay, j omega mu into sigma plus j omega epsilon. So take epsilon common. So j omega mu epsilon I am taking common, so it will be 1 plus j omega epsilon by sigma. So taking sigma common. Okay, since this value is very much less than 1, so this value is very much less than 1, so this can be neglected. Okay, so this value is very much less than 1, so this value is almost nearly equal to 0, so it can be neglected. So what you are left over here is root of j omega mu sigma. So that is, we can write it as root of omega mu sigma angle of 45 degrees. Okay, so because root of j is root of 90 degrees. Okay, so when you have like this, so we can write it as theta by 2. Okay, so root of theta, if you have only angle inside that, so root of theta you can be written as theta by 2, so it will be 90 by 2, which is equal to 45 degrees. Just remember this concept, this is from mathematical concept only. Okay, so when you have only root of j, so root of 90 degrees can be written as theta by 2, so it is equal to 45 degrees. Okay, so this is in polar form, right? So if you write it in Cartesian form, that is normal form, so it will be x plus iy, right? So root of omega mu sigma cos 45 plus root j into root of omega mu sigma into sin 45. Okay, so r at the rate of theta is equal to x plus iy form, right? So what is omega? Omega is 2 pi f mu sigma into this cos 45 is 1 by root 2 plus j into again root of 2 pi f mu sigma into 1 by root 2. So this root 2 and this root 2 gets cancelled off. Here also root 2 and root 2 gets cancelled off. So you are left over with root of pi f mu sigma plus j into root of pi f mu sigma. Okay, this is gamma per meter. Okay, so once you got gamma, you can find alpha and beta. So alpha plus j beta, gamma is equal to alpha plus j beta. So by comparing these two, so alpha is equal to root of pi f mu sigma Nepper per meter. Similarly beta is also same, beta is equal to root of pi f mu sigma radian per meter. Okay, so once you got this, you can find lambda or phase velocity. Vp is equal to omega by beta. So is equal to omega by root of 2 pi f not root 2 pi f mu sigma. Okay, meter per second. Similarly, lambda is 2 pi by beta. So it is 2 pi by root of pi f mu sigma meters. Okay, so all these are the characteristics. We have found gamma, alpha, beta, phase velocity Vp, and lambda. Okay, let me take one more slide. I'll find the value for intrinsic impedance. Okay, so for good conductor, right, so for good conductor, sigma by omega epsilon is very much greater than 1. Similarly, omega epsilon by sigma is very much less than 1. So we are left over with intrinsic impedance. Actual formula is given by j omega mu by sigma plus j omega epsilon. Okay, so take this sigma as common in the denominator, sigma into 1 plus j omega epsilon by sigma. Okay, so this value is very much less than 1, so it is neglected. Okay, so when this value is neglected, what is left over with? J omega mu by sigma. So this can be written as root of omega mu by sigma angle of 45 degrees. Same, root of j is root of 90 degrees is equal to theta by 2 is equal to 45 degrees. This is pure mathematics. Okay, right, so what we have got is theta n, angle of intrinsic impedance. Theta n value is 45 degrees. This is very important point. Theta n, the angle of intrinsic impedance in the case of good conductor is 45 degrees. And we know the relationship between theta and theta n. Theta is equal to 2 theta n, so it is equal to 90 degrees. This is also very important point. Okay, so just have to remember these two. Right, so what does it mean? So when E bar is equal to E naught into e power minus alpha z cos of omega t minus beta z a x cap, then h bar is equal to, so what will be h bar component? It will be E naught by intrinsic impedance magnitude, so it will be root of omega mu by sigma. Okay, so e power minus alpha z into cos of omega t minus beta z minus 45 degrees a y cap. Okay, so this is the wave equation representation in the case of good conductor. Very important. Okay, so when you are solving problems, we again will go through these two formulas. Right, so eta can be written in complex form, right? So root of omega mu by sigma cos 45 degrees plus j into root of omega mu by sigma sine 45 degrees. Yes or no? So eta can be written as root of, what is omega? 2 pi f mu by sigma into 1 by root 2, because cos 45 is 1 by root 2, plus j into root of 2 pi f mu sigma into 1 by root 2. So this root 2 gets cancelled, root 2 gets cancelled. So eta is equal to root of pi f mu by sigma plus j into root of pi f mu by sigma. So this value is called RS and this value is represented by XS. So RS is equal to XS is equal to root of pi f mu by sigma. These are the formulas where RS is called as surface resistance. surface resistance. So eta in the case of good conductor is a complex term which consists of the real part. Real part is called as surface resistance. Excess is called as surface impedance. Surface impedance. Okay, this is the imaginary part of this eta, that is intrinsic impedance. Okay, so these are the formulas for eta, and these are the important points. So theta in 45 degrees, theta 90 degrees, and these are the wave equations. Okay, and eta is a complex term which is represented as a sum of surface resistance and surface impedance, which are given by these formulas. So both have the units as ohm only. Okay, so let me take one more slide. I will explain the concept of skin depth also. Okay, it is related to good conductor concept only. So I will explain the concept of skin depth in this video only. So next we will learn the concept of a small concept of skin depth, or it is also called as depth of penetration. Okay, so skin depth, or it is also called as depth of penetration. Okay, so I'll explain the concept here. So for good conductor, right, so for good conductor, sigma is equal to infinity. So conductivity is infinite, but alpha is not equal to 0. Okay, even though it is a good conductor of infinite conductivity, alpha is not equal to 0, because we have got alpha is equal to root of pi f mu sigma. Okay, per meter. Why sigma is equal to infinity for good conductor? So tan theta is tan 90. Tan 90 is infinity. Infinity can be written as 1 by 0 is equal to sigma by omega epsilon. Okay, so sigma is equal to infinity. So when tan theta is equal to infinity, tan 90 is equal to infinity, infinity is equal to sigma by omega epsilon. So it implies sigma is equal to infinity. So that is why sigma is equal to infinity for a good conductor. This is one of the important point which you have to remember. Okay, so when alpha is not equal to 0, then wave always gets attenuated. Okay, wave always gets attenuated while traveling through medium, while traveling through the medium, that is through good conductor. Okay, so wave always gets attenuated. Okay, so E of z comma t, the formula for wave equation is E naught into e power minus alpha z cos of omega t minus beta z into ax cap volt per meter. So this is attenuation here. Okay, so this is the amplitude. Okay, so always there will be attenuation. Okay, this is the first point which you have to remember. So there, when the wave is traveling, there is always attenuation, right? So now I am telling you the definition of skin depth. Skin depth is the distance. Skin depth is the distance at which EM wave amplitude will decrease. EM wave amplitude will decrease to 36%. EM wave amplitude will be decreased to 36% of its original value. Original value, or 36% means 1 by E. 1 by E times of original value. Original value. So we know that as distance increases E of z, so E naught into e power minus alpha z. So as wave travels, okay, along the distance z, it always gets attenuated. So this is the formula for E of z. Okay, so it should become, so skin depth is represented by del. Okay, so this symbol del. So skin depth is the distance at which EM wave decreases to 36% or 1 by E times of the original value. So that means E naught into e power minus alpha into del. Okay, so when you substitute Z with skin depth, so this value must be equal to 1 by E times. 1 by E times means this value should be equal to e power minus 1. So 1 by E means e power minus 1. Okay, so if you substitute Z is equal to, this is substituting Z is equal to del. When you substitute Z is equal to del, skin depth is the distance at which amplitude will decrease to 36% of the original value, or 1 by E times of the original value. So when you substitute with the del, that is Z is substituted with del, its value must be equal to 1 by E times the original value. Okay, so equating these two equations, what you'll get? Alpha into del is equal to 1. That is, del is equal to 1 by alpha. Del is equal to 1 by alpha. Okay, so it is in meters. Okay, so this is the formula for skin depth. Skin depth is equal to 1 by attenuation constant, inverse of attenuation constant. Okay, so for perfect conductor, different cases we'll take. So first case, perfect conductor. Okay, so for perfect conductor, right, so what is the alpha value? Alpha is equal to infinity. Okay, perfect conductor means wave cannot travel, wave cannot propagate through perfect conductor. So alpha is equal to infinity. High attenuation, so wave cannot even travel through the perfect conductor. So alpha is equal to infinity and skin depth is equal to 0. Okay, that means you will get 1 by E of the original value. Write it origin only, at the start only you will get that. Okay, next lossless medium. If you take loss, just now we have seen in my previous video, so lossless medium. In lossless medium, alpha value is 0. When alpha is 0, del is equal to infinity. When alpha is equal to 0, there is no attenuation. So when there is no attenuation, there is no decrement of amplitude of the electric field. Right? So when there is no decrement, so never skin depth will arise. So del is equal to infinity. Okay. Similarly for this medium, for good conductor. Okay, so for good conductor, what is alpha value? Alpha is equal to root of pi f mu sigma. So del is equal to 1 by root of pi f mu sigma meters. Okay, so this is the value of del in the case of good conductor. Okay, so for different medium, you just have to remember the value of skin depth. Okay, for all the competitive exams, all these points are very important. So last point is relation between del and RS. Okay, relation between del and RS. So we have seen del is equal to 1 by root of pi f mu sigma. Okay, for good conductor, it is del is equal to root of pi f mu sigma. Similarly, for good conductor, what is RS? Just now we have got RS is equal to root of pi f mu by sigma ohms. Okay, so if you multiply RS into del, so it will be 1 by root of pi f mu sigma into root of pi f mu by sigma. So pi f mu gets cancelled, so it will be 1 by sigma. Okay, so RS is equal to 1 by sigma into del. This is the relationship in ohms. Okay, so this is the relationship between skin depth and surface resistance. Okay, so just remember all these points. So that concludes your good conductor characteristics. Okay.